Okay, ladies and gentlemen, welcome back for another video. And at this time, I would like to share some ideas when it comes to massive amounts of launch capacity. Okay, so right now, company SpaceX is developing a pretty big rocket, as many of us are well aware, and hoping to launch people to Mars. And Elon Musk has talked about potentially, having a colony of 1 million people or more on Mars. So right now they're developing the rocket, and it's amazing technology. I love the technology. Um, and right now they're developing the technology down here in Boca Chica Beach, which is right over here somewhere. Yeah, somewhere in that range neighborhood. Oh, there it is, Boca Chica. Older satellite image. But anyway, um, and NASA's launch facilities are over here, mostly in the Cape Canaveral area, which is right around here. But one thing that's important to note here is that these launch facilities are, say, Cape Canaveral here is at 28 degrees north, all right? And Boca Chica Beach is 20. I just looked at it before. It was like 26 degrees north of the equator. So you might already be aware of this, but when the Earth is spinning, it already has like a certain amount of speed to it. And you launch toward the east because it takes the speed, the existing speed that the Earth already has, and gives you that much more, speed toward reaching orbit. Okay? And it's something like 1,100 miles per hour. I have it written here. So, speed of Earth's rotation, not 1,100 miles an hour. The speed of Earth's rotation at the equator is 1,038 miles per hour. That's just straight from Google. Okay? But the speed of Earth's rotation at Cape Canaveral, which is 28.47 degrees, is only 869 miles per hour. Why does this matter? It doesn't. It doesn't make a bit of difference if you're launching once a month, 10 times a month, 100 times a month, even maybe even 1,000 times a month. It doesn't even make a big difference. But when you're trying to launch 1 million people to Mars, and that's a lot of launches. I mean, you might have 100 people. You might have 100 people on each launch, but that's still like what, 10,000 launches to get to 1 million people. All right, and and then also the launches for all the material to make it survivable, all the machines and equipment that they need. So, clearly, at some point, it's going to make sense to have launch facilities that are on the equator. Like, it just makes sense. All the material and stuff you can transport by boat, and then all the people can fly down on much more efficient airplanes, fly down to the equator where that launch facility is, and then launch from there. So I was looking at this. I looked at this numerous times over the years. And let's go switch over to Google Earth. So, zooming back out, what we need to find is an equatorial area that would be on the eastern side of a landmass. So if you look at the entire equator, there's several places where it's on the eastern side of a landmass. That way, all these launches are going over the water. You're not like launching from the middle of Central America or the west side, and then all these launches could potentially fail, and some of them could inevitably fail and crash and kill people or hurt wildlife, and it's less likely to hurt wildlife in the ocean. Although there's some wildlife, obviously. Um, so there are several places along the equator where you have, um, well, like the western side of a landmass that intersects the equator. So here you have this little island, basically, that's called the Ilha de Mexiana. It's at the mouth of the Amazon River. Okay, and then scooting along the equator, you get another one over here in Somalia. All right, and then you get what is this? Indonesia, Singapore, or not Singapore, but Indonesia. Along this island and all these other smaller islands. So, and that's about it. That's about it, because then keep going around the equator, and you get back here. So, this idea came to me years ago already, and it also ties into another idea I had many years ago, like back in 2014. When they first announced the South Padre, or the Boca Chica village launching and testing facilities or whatever, when SpaceX first announced that they were establishing facilities there, I thought it was pretty awesome. And I went on to SketchUp, which was like a free 3D program, to do some basic 3D modeling and look at what a launch facility would look like if it wasn't just like one launch pad, but like a lot of them. Okay, so here we go. So this is my model from around 2014. This says SketchUp Make 2017. That is the program, but this file was made in, I think it was around the summer of 2014 or spring of 2014. And this is a huge file, by the way. I built this on a laptop and was somehow able to move it around and make it work. But like, even on my much more powerful desktop computer with a 3090 card, it's still to this day is troublesome to move this file around. So, how do I? Thought I could select things. Well, how come I can't move it? Okay, so anyway, I can just go like this. Oh, that's right. It's different than Google Earth. Duh. It's been a while since I've been in SketchUp. But anyway, so this is a model for a launch facility where you could have dozens, maybe 100 or more launch pads for, at the time this was BFR rockets, but now we're deep into the Starship design. And so for scale, you have some examples here. There's your not even current Starship, that's from years ago already. And you got your Ares rocket, your Saturn V, Falcon 9, and over here you got your space shuttle. And then this was my design for a BFR rocket that everybody has their own window, and if this is pointed downward toward, like if this point was downward toward the Earth, then everybody could look out their own individual window. But anyway, I digress. So this is just a concept, and I pictured this being, and when I originally made it, I pictured this being in like Boca Chica or maybe Florida or something else. But later on, a few years ago, I came up with the idea of putting this same design, the same launch facility, in what's called Ilha de Mexiana, which is that little island at the mouth of the Amazon River. It's right on the equator, and it's much, much bigger than this area. So let's go back to that and I'll show you the measurements. So if we go down here, and there's Ilha de Mexiana, all right? And so we're going to measure it. Just along the equator, that's 42 kilometers. So that's 24, it's like 25 miles across. So that's plenty of room for a launch facility like I just showed you. But just recently I did a lot more like napkin math, and I was kind of figuring things a little bit, and like, what's the maximum number of launches that could be sustained on the equator? Like, if you just really built out the infrastructure, like how long would it take to launch the entire human race off of Earth? If you had launch facilities completely maxed out on the equator, there isn't like an infinite number of spaceships that can be launched. There's not an infinite number of rockets that you can send up on a given day, because you get up to thousands and thousands of them, and all of a sudden you have, like, on the equator up in space, you've got like traffic forming with with all these thousands of spacecraft. So let's go back here. I want to share some of my other ideas. So based on my napkin math, you could have, on the Ilha de Mexiana, you could have up to 4,000 launch towers. And Starship rockets, I consider them in like a 10 meter wide by 100 meter tall class category. Obviously, the real dimensions are 9 meters wide diameter, and like 120 plus meters of height for the Starship. But there's a few other rockets that are being developed in that class, and in the future they might be more common. And if you were going to like scale up from there, potentially it's possible, I mean, according to what I've read online, it's possible to make a 100-meter diameter rocket by 1,000 meters tall. And I don't think it could get much bigger than that, just because of the strength of materials and just the properties of rocket dynamics and everything. But if you were able to develop a rocket that big, you could put 250 of those launch towers on Ilha de Mexiana, and launch, according to this calculation, 500,000 per day. I'd have to double check that, to be honest with you. But the other facilities you would need, not just launch facilities, you need a port on the island, you need a subway system. I mean, we're talking massive amounts of people here. A subway system, a shipyard, for ships, for actual ships, because you're going to want to be able to have repair facilities for the amount of ships that are coming and going. You're going to want to have a little bit of ship repair, the giant launch facility that we just discussed, rocket production. Now this is like rocket production on a gigantic scale. So warehousing, storage for all the parts and materials, roads, of course, water production, fuel production. All this has got to be stored. Housing, hotels, airport. Probably one airport, one major, like, we would grow into a major airport. Stormwater management, just everything that it takes to build a city based around, it's like a company city that is based around a launch facility. So, so back here. So let's say you had this launch facility in roughly this area. I would say that having the airport over here makes sense, and having the production facilities here. And I don't know where you'd put the port, because you don't want it too close to the launching. So anyway, just some rough ideas here. And to be honest with you, just so you know, this whole entire island is like a wildlife sanctuary, which is important. I get that, it's very important. But if we're going to save humanity and do it in the most efficient way, without destruction of too many other areas, I think sacrificing this island actually makes sense. But you guys be the judge of that. This is just an architecture, okay? um, this is just a conceptual architecture, and I'm not a big politician, so I won't be like pushing this. I won't be trying to get like a lot of people behind me or anything, okay? So, now, well, back to the notebook real quick. We covered that. We covered that. Oh yeah, regarding the climate on the equator, uh, doing some reading, I discovered some cool things about the equator. Now, the equator, generally speaking, the temperatures around the 80 to 90 degrees every day, 365 days a year, which is a little bit hot when you have cryogenic um, facilities, cryogenic propellant at these facilities. So, um, but one thing I noticed was, of course, it's nice that it's consistent. You know, you don't have huge temperature swings throughout the year. That you build your infrastructure based on what what you need for a smaller temperature range. Okay, and um, so on the equator, it's particularly in Ilha de Mexiana, it's moderate, wet, dry seasonality, warm and humid. It rains a lot, and there's fewer daylight hours. There are other latitudes, like I think it's like Tropic of Cancer or something, actually gets more daylight throughout the year. Don't take my word for it. We're gonna click here. I'll show you. I'll show you what I found. It is, where's this graph? So this graph right here. So the Arctic Circle actually gets more sunlight throughout the year than the equator. I was really surprised by that because I know that, like, you know, it can be dark all winter long in the North Pole or something. I don't know. I'm no expert on these things, but I just did this little Google search, and it looks like the equator actually gets not, not that much daylight compared to other places, which is good for a cryogenic launch facility. Because not so much just the heat in the area, in the environment, is what's important, but also the sunlight beaming down on these rockets. The sunlight actually directly hitting it is going to make it harder to cryogenically freeze the propellant. So, or to maintain that cryogenic temperature. So, with the rain and humidity and the clouds, and the lower amount of daylight, it seems like the cost of maintaining those cryogenic temperatures is actually a little bit better. This is, it works to our benefit if you're trying to launch thousands of rockets a year, or even thousands of rockets in this case per day. So, and so that was the Ilha de Mexiana. So that would be, like, in my opinion, that's like the first place to set up as a mass launch center. Okay. But you could max that out and still have capacity to launch more rockets around the Earth, to send more people to Earth, to orbit. I'm sorry, to orbit and beyond. So the thing is, most people live. I mean, there's a lot more people who live up here than there are down here. But then there's also a lot more people who live here in India, here in China. I mean, these are like really high density population zones, especially like Southeast Asia. So what I noticed was, if you look at the latitude and longitude of Ilha de Mexiana, okay, and you figure out what's the antipode, the opposite side of the Earth on the equator, Okay, and the antipode is, it's this island right over here. It's called Waigeo. Waigeo. So let me show you the specific stuff that I came up with. So, um, get past that. Where was it? Here it is. So at 50 degrees west, now remember it's 0 north and south, right? But 50 degrees west is where Ilha de Mexiana is. 130 east is where Waigeo is. And that was here. All right. And then you have 40 east. Now, this is like midway between Ilha de Mexiana and Waigeo. So it's exactly midway is 40 east, Garissa, Somalia. Now remember we were looking at the equator before and we saw this little spot where the equator intersects with the west coast of Africa? Well, Garissa is like literally like right over here. 40, what was it, 40 east or something like that? Anyway, I found it before. I'd have to look it up again, but it's right along. It's not far from the coast. So literally, you could have equally spaced, massive mega launch facilities. If you start with one at Ilha de Mexiana, and then you go to the opposite side of the Earth at Waigeo, which is this one, and then your third one might be here on the coast of Somalia. Okay? And then by that point, we're talking probably 100 years from now or more. If they needed a fourth one, you'd be in the middle of the ocean. You'd be in the middle of the Pacific. But, now where would it be? Where would it be? I have it written down. So 140 west in the Pacific Ocean. So that's over here. Wait a minute. 140 east, 140 west is here. So if you needed a fourth mega launch facility, you could do something here if you build an entire island, floating island, on the ocean, which I think, I imagine that's possible like a couple 100 years from now. But anyway, not important. So what is important to note is if you have thousands of rockets launching from here on the equator, and then you have thousands of rockets launching from Waigeo on the equator, and then you have thousands of rockets launching from Somalia on the equator, you're really quickly going to have some traffic to deal with. So at some point, you're really going to overwhelm the circumference of the equator that in space, like with too many rockets. They're just going to be too close to each other. So here's why instead of Ilha de Mexiana, I actually picked a different island to be the ideal place to start this. So this is Ilha de Mexiana. And I thought, why don't you offset these locations, these launch spaces? Because, if you had one that was above the equator, and then the second one was below the equator, and then the third one was well above the equator, like, 25 minutes north or whatever. So this island, what's it called? I have a name here. Ilha Caviana. I had to find these names. It's not easy to, you can't just zoom in on Google Earth and see the name of the island. Ilha Caviana. Sorry about my phone. Let's just turn the volume down. Ilha Caviana is this island right here, and it's actually much bigger. So that would be the place I would actually say is the ideal place to start a mega launch facility, not Ilha de Caviana. Okay? Sorry. Not Ilha de Mexiana. Ilha de Caviana, because it's offset from the equator, which means that once you get the entire planet built out with this massive launch capacity, then that would be the ideal end game if you're looking at the end game. So you'd have here Ilha de Cabiana, and then Waigeo is already a little bit below the equator, so you could have that offset down by say 10 degrees, and then you could put you've got more leeway here to offset where you want to be, whether it's 20 degrees, maybe 20 degrees north or south, and then the fourth one would be 20 degrees north or south. Okay, the eventual fourth one in hundreds of years later. So this is like development with an end game in mind. Okay, so that's my idea for mega launch facilities. You might say, hey, what about like space elevators and stuff like that? Well, yeah, space elevators are great, and I hope that becomes a thing. Yeah, this thought experiment didn't really take that too much into account. It's just like, what if you really wanted to maximize the build out of launch facilities on the equator? This is how you would organize it, and let me know what you think. By the way, that huge rocket, the one that's like a whole order of magnitude bigger than Starship, 100 meters diameter by 1,000 meters tall. I'm calculating that you would want 100 engines, and each engine would be 9 meters wide. This is preposterous by today's current technology, but it's just plausible. It's possible. And I even did some napkin math on what other configurations are like for different sizes. So anyway, that was my concept for building massive launch facilities. When you do have these launch facilities, you can do things like put these cranes on rails. So these are all rails that can transport the cranes. You can also have huge wind generators, wind electric generators, and then you could transport people to these launch facilities with underground rail subway systems, like high-tech, modernized, maybe maglev or something, or what was Elon's idea for pneumatic tubes or something like that. But yeah, if you have any thoughts or ideas regarding my architecture, please let me know. Again, this is Rich Allen, signing out. Thank you.